This is the lesson activity for lesson 20 in college algebra. Consider the quadratic function f of x equals negative x minus 1 squared plus 4. Identify the values of a, h, and k. So a is going to be negative 1. It's the coefficient in front of the parentheses. H is this value right here, which is a 1. And k is this value right here, which is 4. What is the vertex of the parabola? That happens at h comma k. And we just identified h and k as 1 and 4. Does the parabola open up or down? We look at the value of a. And when the value of a is negative, that means the parabola opens down. Find the y-intercept of the parabola and the point symmetric to it. So y-intercepts for any function you find by making x 0. Just remember, you can draw yourself a little picture. Y-intercept means a point on the y-axis, and we always know the x-coordinate of that point is 0. What we're looking for is the y-coordinate. So I can make the x 0, solve for the y. So I'm going to do f of 0, negative 0 minus 1 squared plus 4, which negative 1 squared is 1, but then there is an additional negative outside. So this is negative 1 plus 4, which is 3. So my y-intercept is 0, 3. I find it easiest to start graphing the parabola before I try to find this point symmetric to the y-intercept. Okay, so I'm going to start putting the things I know about this graph in the axes. So I know the vertex is at 1, 4. I know it opens down, and I know its y-intercept is at 0, 3. Okay, so then I can find the point symmetric to that by drawing in the line of symmetry that goes vertically through the vertex, and then draw in the point symmetric to the y-intercept on the other side of the line of symmetry. So it'll be right here. Visually, we can just reflect over that line of symmetry and then figure out the coordinates of this point, which are 2, 3. So 2, 3 is the point symmetric to the y-intercept. And then last, we want to find the x-intercepts and graph the parabola. So x-intercepts, remember, if you're on the x-axis, we don't know the x-coordinate, but we do know the y-coordinate is 0. So I'm going to make y in this formula 0 and solve for the x. So I have 0 equals negative x minus 1 squared plus 4. And I'm going to use the method of extracting square roots. So I'm going to add x minus 1 squared to both sides. So I have x minus 1 squared equals 4. Then I'm going to take the square root of both sides. The square root of x minus 1 squared is x minus 1. And when I take the square root of 4, I'm actually going to write plus or minus 2. Right, because there are two numbers you can square to get 4, 2 and negative 2. And then I just add 1 to both sides. Okay, so I get x equals, if x minus 1 is positive 2 plus 1 is 3. And if x minus 1 is negative 2 plus 1 is negative 1. So my y-intercepts happen at 3 and at negative 1. And then I connect with a nice smooth curve. So far, we've been given the parabola's equation and then drawn its graph. We can also go backwards and get an equation if we are given the graph. So we're going to use the steps listed down here, okay, to find an equation for this graphed parabola and put it in this form, a times x minus h squared plus k. Okay, so the vertex I can identify from the picture is at 3, 5, which means I know in this formula, I know the h is 3 and the k is 5, right? So I'm just going to put those in. So x, this is written a little too small, so I'm going to write a times x minus 3 squared plus 5. And then you can use either of the points given, any other point on the graph will work, to find what this coefficient a is. Okay, so, right, this is y equals a times x minus 3 squared plus 5. And if I have another point on the graph, I know the x coordinate and the y coordinate. So I'm going to replace the x in this formula with a 0, the x coordinate, replace the y in the formula with the y coordinate of 23. So I'm going to have 23 equals a times 0 minus 3 squared plus 5. And now I have an equation where the only unknown is a, and I can solve for it. So I have 23 equals 9a plus 5. Subtract 5 from both sides, and I have 18 equals 9a. Divide both sides by 9, and I get a equals 2. So my final equation is going to be y equals 2 times x minus 3 squared plus 5. So I already had most of it, and then once I figured out what the a was, I replaced it with the 2. And then finally it says change your function to the general or the polynomial form ax squared plus bx plus c. That just means multiply this out. So I'm going to have f of x equals 2 times, carefully following the order of operations, you square things before you multiply, so I'm going to do this x minus 3 squared first, and x minus 3 squared is x squared minus 6x plus 9. Then I'm going to do the multiplication, so I distribute the 2, so I have 2x squared minus 12x plus 18, and then the 18 plus the 5 gives me 23. Consider the quadratic function f of x equals 4x squared minus 16x plus 1,000. Determine, without graphing, whether the function has a minimum value or a maximum value. Well, the a value, the coefficient on the x squared, tells me that this graph opens up because it's positive. 4 is a positive number, so this is a parabola that opens up, which means it looks like this. And that means that the vertex is the lowest point on the graph, so the function has a minimum value. Now I want to find that minimum value and determine where it occurs. So that is, find the coordinates of the vertex. So the x-coordinate of the vertex we call h is negative b over 2a. Okay, 4 is my a, negative 16 is my b, 1,000 is my c when I do the quadratic formula. It's the same for this formula, negative b over 2a. There's no c in it, I only need the b and the a. So the opposite of b is positive 16 over 2 times a, which is 4, so 16 over 8 is 2. So I know the x-coordinate of the vertex, and then the y-coordinate of the vertex, we call k, is just going to be f of 2. So I just found the x-coordinate. If you want to know the y-coordinate that goes with an x, just plug it in. So I'm going to have 4 times 2 squared minus 16 times 2 plus 1,000. 2 squared is 4. 4 times 2 is 16. 16 minus 32 is negative 16 plus 1,000 is 984. So my vertex is at 2, 984. So I'm going to write that here. Vertex 2, 984. That is the lowest point on the graph. That's the minimum. And then the 984, that's what measures high or low on a graph, the vertical position. So we call that the minimum value. So the minimum value is 984. And it occurs at x equals 2. So now that I know where the minimum value happens, I can identify the domain and range of this function, because I know that it looks like a parabola whose vertex is at 2, 984. So the domain is going to be all real numbers. Any quadratic has no restrictions on what you can plug in. But the range, we'll go from the lowest y value to the largest y value. The lowest y value is 984, and it goes up to infinity. Number 4, maximizing area. A farmer has 400 feet of fencing to enclose a rectangular corral. To save money and fencing, he intends to use the bank of a river as one boundary of the corral. So draw a rectangle below that models the situation and label each side of your rectangle, and one side is a river. So I'm going to put a little squiggly line for my river, and then I'm going to build a rectangular corral up against the river, like that. Okay, so to label the sides, I don't know the exact dimensions of this corral, so I'm going to say we'll call this one X, and the side opposite is also X because this is a rectangle, and then the third side we'll call Y. Okay, and I want to describe each of the variables. So X is the width, I guess, width of the corral in feet, and Y is the length of the corral, also in feet. And then I want to write two equations, one for perimeter and one for the area of the rectangular corral. Okay, so perimeter is the distance around, so I have 2x plus y, and I'm only counting the distance that I enclosed with my fencing because the river was already there. So it's just 2x plus y, and I know that that distance is 400 because I only have 400 feet of fencing, so I can put a 400 in for the p. And then area is just x times y, length times width for a rectangle. All right, I want to find the dimensions that would enclose the largest area. So first, rewrite your equation for area of the corral in terms of the width or the length, but not both. So I only want one variable. So I'm going to use my perimeter equation to solve for, say, y. So I have 400 equals 2x plus y. Solve for y, and I get 400 minus 2x. And then in my area equation, which is x times y, I can replace the y with the expression I found in terms of x. So 400 minus 2x. And then when I distribute, I get negative 2x squared plus 400x. And I have a quadratic equation with a graph similar to this one because this is a quadratic equation that opens down. We've got this negative here, opens down. So I want to find the coordinates of this quadratic. That will give me maximum area. Okay, the vertex will give me the maximum point. So the x-coordinate of my vertex, we call that h, and it is negative b over 2a, so negative 400 over 2 times negative 2. So that's negative 400 over negative 4 is 100. And then k, the y-coordinate of the vertex, is the area when x is 100. So it's going to be negative 2 times 100 squared plus 400 times 100, which comes out to 20,000. So this is the vertex of my parabola. I know that its coordinates are 100, 20,000, and x represents width of the rectangle. And then my y-coordinate is a, area. So I'm just going to write that over here, area. So the largest area possible is 20,000 square feet. It happens if we make x 100 feet. So this is our final conclusion. The largest corral is 20,000 square feet if we make x 100 feet.